Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the reduction rules for POS using K-map. So as we know, the product of sum or POS is the product or ANDing of the max terms. So as we discussed in early lectures, if we are considering a three variable, let us say variable be A, B, C, and the max term M0 is 0, 0, 0, which is represented as A plus B plus C. If we are representing the max term 1, 1, 1, then the max term will be M15, which is equivalent to A bar plus B bar plus C bar. Thus, it is evident that the binary 0 is represented as variable itself in max term, and a binary 1 is represented as a variable complement, and each of the individual variables are added to get a max term. So here in this lecture we are discussing the different rules for K-map solution. There are a couple of rules that we use to reduce POS using K-map. First, we will cover the rules step by step, and in the next set of lectures we will solve the problem using these rules. Firstly, we are discussing the pair reduction rule. Let us consider a 4-variable K-map as shown in this figure. Now we mark the cells in pair having the value of 0. So in the SOP we had marked the pair with the values 1, but in the case of POS we should mark the cells with the value zeros. So thus we can get two set of pairs. The first pair is W plus X dash plus Y plus Z and W dash plus X dash plus Y plus Z, and the second pair is W plus X plus Y dash plus Z dash into W plus X dash plus Y dash plus Z dash. Now we will remove the variable that is changing in the first and second pair. Looking at the first pair, we can see that the W is changed to W dash, and in the second pair X is changed to X dash. So we should remove W and X in first and second pair, and thus the updated pair after removal or reduction will become: first pair is equal to X dash plus Y plus Z, and the second pair will be W plus Y dash plus Z dash. So this is the reduction rule or pair reduction rule for POS. So the second set of rule is a chord reduction rule. So we should consider the K-map as shown in this figure and mark the cells in chords, that is the set of 4 having the value 0. So here we can see that two chords are formed with the cells 0, 4, 12 and 8, and the second chord is 3, 2, 7 and 6. So the first chord is equivalent to W plus X plus Y plus Z and W plus X dash plus Y plus Z and W dash plus X dash plus Y plus Z and W dash plus X plus Y plus Z, and the second chord will be W plus X plus Y dash plus Z dash dot W plus X plus Y dash plus Z dot W plus X dash plus Y dash plus Z dash dot W plus X dash plus Y dash plus Z. Now we should remove the variables that is changing in the first and second chord. Looking at the first chord, W dash and X dash are changed to W and X, so we should remove them. And looking at the second chord, X dash and Z is changed to X and Z dash, so we should remove them. So the updated chord after reduction will become: first chord is equal to Y plus Z and the second chord is equal to W plus Y dash. So here we can see that a chord reduction rule remove two variables in each of its individual term. So now let us consider the octet reduction rule. The octet reduction rule is considering as per this following given K-map. So mark the cells in octet, that is a set of 8 having the value of zeros. So here we can see a single octet with the M0, M1, M2, M3, M4, M5, M6 and M7 forms the octet, and we should remove the variable that is changing in the octet sets. Looking at the octet, moving from top to bottom, X dash is changing to X and moving from left to right, y dash is changing to y, and moving from left to right, z dash is also changing to z. So here the updated octet after reduction will be w only. So here we can see that in the octet reduction, the octet rule will remove 3 variables in different individual terms. So my dear students, when we come to the map rolling reduction rule, the first set of map rolling is map rolling pair rolling. In this we should consider a K-map's top edge is connected with the bottom edge and the left edge is connected with the right edge, and then we mark pair, chord and octet, etc. And let us consider the first one, that is marking the pair. Considering the following K-map, the first pair is formed with M1 and M9. So this pairing is done with a cell in the top and cell in the bottom, and also the second pair is formed with M12 and M14. These cells are formed by pairing the left cell and the right cell, and after reduction the first pair will become x plus y plus z dash, and second pair will become w dash plus x dash plus z. Similarly, in the case of a chord marking also, we can mark the chord based on this principle. Let us consider this figure. Here we can form the first chord by pairing or marking the cells M1 M3 in the top row and M9 M11 in the bottommost row. Here also we can mark the second chord with M4 M12 with M6 M14. So applying the different rules, the chord after all the reduction will become x plus z dashes will be the first chord and x plus z will be the second chord. Similarly, we can mark the octet based upon this reduction rule also. The fifth major rule is the overlapping group rule. When a value in a cell of a K-map is encircled in more than one group, that group may be pair, chord or octet, then we can call such a group as overlapping group. Let us check this example. Consider the following K-map. The first pair forms M4 M5 and the second pair is formed between M15 and M14. So here we can also see a chord with M5, M7, M13 and M15. Now if we look at M5 and M15, they are overlapping. The overlapping groups helps in getting simple expressions after reduction. And finally, we should consider the redundant group rule. After marking out the overlapping group, it is important to also check for redundant group. If all the values of a group G is covered with other group, then the group G is redundant and ignored. Let us consider an example. For finding a redundant group, consider the following 4 variable K-map. Here the first pair is formed by M5 M7, second pair is formed by M12 M13, and here we can also form a third pair by M5 and M13. Here if you look at the M5 and M13, that is a third pair, it is a redundant group as M5 and M13 is already covered in the first and second pair. So we will remove the redundant group, that is the third pair, since these cells are already covered. If it is not yet covered, we can consider it. Since it is already covered in the first and second group, we should not consider the third group. So my dear students, if we are summarizing the reduction rules for POS using K-map, the first point should be remembered is prepare the truth table for the function. Secondly, draw an empty K-map with 3 variable, 2 variable, 4 variable or a given set of variable. Third point is fill the cells with the value 0 for which the output or function is 0. Fourthly, fill the rest of the cell value with 1. And fifth point is mark the octet, chord and pair by encircling the values of 0. Also we should check the map rolling, map overlapping and remove the redundant groups, and finally and the reduced expression to get the final answer. When we are considering a cell from top to bottom, or from left to right, the variable for the final answer or the reduced set should be an unchanged variable if we are moving from a cell from top to bottom or from left to right. That is, we should consider only the variables that is not changing to the final set of answers. So my dear students, hope you had understood this topic. So dear students, kindly write down this assignment. The assignment question is, write about the reduction rules for POS using KMAP. So my dear students, in the upcoming lecture we will discuss the different examples or problems to solve a POS using KMAP. So see you soon. Until then, goodbye, thank you, and all the best.